Okay, thanks everyone. So I'm going to present today on modelling the weather of the 21st century, and there's a list of names here of people who've helped develop this talk and the content that I'm talking about, and I'm just really representing our views as a team. So what is our motivation for doing high-resolution modelling? So my talk's towards getting a kilometre-scale resolution version of the ACCESS model. And you can see here, and Tomoki also really nicely introduced this, as the motivation is that some of these really small-scale structures in the rainfall here, which is shown from satellite, that we're not able to capture in our CMIP kind of resolution models. And you can see on the right the elevation from the 100-kilometre version of the ACCESS model compared to the 5-kilometre version. You can see Tasmania is not really there. We don't get the East Coast mountain ranges. The highest mountain ranges are in the interior of the desert, which we know is not true. And importantly, that then will affect some of the information that we give to policymakers about projections going forward. So we have a Centre of Excellence for 21st Century Weather. This is funded by the Australian Research Council. It's across 5 universities in Australia with lots of other partners. And this is a schematic of our proposed science that we're intending to do. And so we're trying to get away from thinking just at global scale and regional scale climate change, but really about the weather systems that are really going to inform projections of the future. So we launched in February. We're really just spinning up, but we have started thinking about some of the science questions that we're really wanting to ask, and we've been in a really intense hiring phase. So we've organised into different projects around climate variability and weather interactions, weather systems in a warmer world, weather resources, and high-impact weather. But importantly, underpinning those 4 projects are cross-cutting projects as well. And so I'm here representing the Modelling Science Project, which is really to design and apply kilometre-scale global and regional models to some of the science questions we're asking. So who's in the team? Here's just a picture of the people that we've got so far. A lot of chief investigators from across the 5 universities. We've hired some software engineers that are coming on board, and also starting to hire some research fellows. We've got more to come, so we're every week we're adding more and more people, and so by the end of this year we should have hopefully a fairly full contingent. So why do we need high-resolution modelling? So we're arguing that we need a global high-resolution fully coupled model at 25 kilometres atmosphere and 10-kilometre ocean or higher. So this is sort of our first goal. And part of the motivation comes from this image, which is showing the CSM SST trends over the observed period, satellite era. So on the top you can see the SST trends from observations, and you get this sort of Southern Ocean cooling and tropical Pacific cooling. And then in the CSM1 model, this is the low resolution result, and on the right is their high resolution global coupled model. And you can see that the high resolution model does a much better job at representing those observed trends. But the current understanding of the processes involved in that improvement is really limited. And so we want to ask, what's the role of small-scale coupling between the atmosphere and the ocean in some of these questions? We can't run really long kilometre-scale resolution simulations, so can we design short experiments to really understand what's going on here? And yeah, is high resolution in the atmosphere or the ocean or both the critical part? We also intend to develop a large domain regional coupled model. So coupled atmosphere, land, ocean at 5 kilometres or higher. And so here I'm just showing the difference that you get from 1 kilometre, quarter degree, 10th degree in the ocean, and some of these ocean eddies that might really have that imprint onto the atmosphere, and so that atmosphere-ocean coupling again. And then here in the middle is the fraction of grass in different land ancillary files, and so here's at the 5 kilometre resolution, you get a much better representation of that. And so this would be a new development for ACCESS. So ideally, we're going to develop with similar coupling to the global model. We would like a flexible domain size that can easily move around. And we could start maybe with a large Indo-Pacific domain, but also have small idealized domains to really test some of these questions, such as what role do eddies play in air-sea coupling and large-scale upper ocean heat content, and how do small-scale gradients impact tropical cyclones and coastal processes. So they're some of the research fellow projects that we've hired. And there is some evidence that with high resolution, you do get different coupling also between the land and the atmosphere. So this is a figure from a recent paper by Lee and Honegger using the ICON model out of the Max Planck Institute. And you can see at the CMIC kind of level resolutions, 160 kilometres, this correlation between soil moisture and rainfall is positive. But if you go to high resolution, it gets much weaker, more in line with the observations. And so the argument is that these coupling between the land and atmosphere is very different in these high resolution models, and that can really impact our projections and understanding of drought and heat waves, for instance. And then we are also arguing that we need an Australian domain regional model at kilometre scale resolution. And so we have, right now in Australia, we have the AUS 2200 regional atmosphere land model. So that's 2.2 kilometre resolution. We're transitioning that now with the help of the NRI to the Unified Model Regional Nesting Suite. And so Shamel Engel is going to give a talk on that, and Chris Chambers is also talking in this session on some science results from this version. And we want to make, really have the science goal is to have this regional model be relocatable domain again and have nests to sub-kilometre scale resolution. So we have that by the end of this year, hopefully with Jules, the land surface model Jules in the UM. And then there's been a lot of scoping work within CLEX as well to develop a cable UM version of that. And I guess key to that is that we need both improvements in parameterizations and land surface ancillaries. And so I guess the key point is that in developing high resolution models, the land actually gets harder. The atmosphere and the ocean potentially gets easier. So some of the questions are, can we run experiments with both land and water temperature gradients to get at these kind of coastal processes? And also particularly with thinking about urban, we need to develop scale-aware parameterizations. And just a note that there's going to be the ACCESS Land Surface Workshop is going to be here in Canberra, I think, on the 9th to 10th of October, talking more about those things. Okay, so in terms of our model development timeline, this is a slide courtesy of Matt Lipson. And so we are working with CSIRO and the Bureau and the NRI to develop our high resolution plans. And so right now we're here, I think a version of the ACCESS AM3 model is almost ready for release. And our aim is to hopefully by the end of this year have a 1/4 degree atmosphere, potentially 10th degree ocean version ready. In terms of, we have this UM regional nesting suite and hopefully becoming more flexible going forward. And then in the future, we're getting towards more and more kilometre scale resolutions with the coupled models. And I just wanted to highlight that we are trying to develop collaborative workflows as we go. So we want to create a database of experiments and data sets through intake catalogues, and here's some adages here to motivate us. So we want these to unite us, and so that we can all use the same model configurations and the same experiments to do our science. We're setting up GitHub repositories of the model configurations so that anything that we develop in 21st century weather could be easy to use by others. And we're really working on having lots of recipes and analysis notebooks so that coding efforts of one person can then have lasting impact and help others move forward. And I guess, and the final one is for individual research projects, we also want to use that GitHub as a project management tool to make interactions easier. Okay, so to summarise, I think there's some really exciting prospects for scientific progress in climate modelling through kilometre scale model development. Our centre, the 21st Century Weather, is developing multiple configurations of the ACCESS modelling suite towards this kilometre scale resolution, as well as these tools to help us set up configurations. And we have multiple national and international partners involved. Tomoki already mentioned this Hackapalooza, which there is going to be a hub at NCI for this hackathon. And yeah, there's more and more people coming on board, so please come chat to myself or any others here about ways we can engage together. Thank you.
Do you see the biggest problem with high-resolution modelling, the technical aspect, and one of resources, or one of kind of inputs and ancillaries? You don't have the ancillaries at the required resolution.
That's a good question. I think we're just getting started, but we're definitely wanting to learn from what others have done, so like Tomoki and people at MPI. But I think for the land, the ancillaries is definitely a difficulty, and there's people at the Bureau and Matt Lipson and Negan Nazarin who are working hard. But yeah, we'll need the NRI's support to do some of the technical things.
Thanks.
Other questions? How long can we run the quarter-degree? How long can we run the quarter-degree ocean? No, quarter-degree atmosphere, 10th-degree ocean.
That's a good question. So we do have resources on NCI, and I guess we, as a centre, are needing to discuss what our priorities are. So yeah, I think you can run it as long as you have the resources, but whether, yeah, what we decide to use our resources for is the question. But we are, I guess, planning in the new centre to have more focus on big community experiments, so large experiments that we'll all analyse, and less sort of these small individual experiments. That way we can get more bang for our buck.